Okay, so we can go for the Karnataka University Dharwad Nehru Arts, Science and Commerce Degree College Hubli. So the content of this video is BSc third semester Mathematics unit groups. In the groups we can take here in the class definition of a group and properties of a group and some theorems. So this video is prepared by Professor T.V. Marigoda, Department of Mathematics, Nehru Arts, Science and Commerce Degree College, Hubli. So this is the second unit of the paper, and the first unit of the set theory is already over. Okay, students, to come across the groups needs the definition of binary operation or binary composition. The group, it needs the definition of binary operation, we can simply called as BO, or binary composition. Whenever we can state the binary operation or binary composition definition, this definition is especially depend on the numbers. The definition are depend on the numbers. Numbers often we can consider as a set. What are the numbers? Usually we know that the natural numbers, counting numbers 1, 2, 3, 4, 5, whole numbers including 0, 1, 2, 3 and so on, integers 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on, and rational and irrational numbers, complex numbers. We are familiar in those numbers. I just recalled those. The definition of binary operation or the group almost all depends on the set. Set is nothing but the numbers are defined thing. Okay, now to come across the definition of a binary operation. Let S be any non-empty set. Non-empty set means S containing or consisting some elements. Let S be the any non-empty set. An operation, a new operation, we have to be write by means of the star. A diagram, the symbol is a star. Let S be the any non-empty set. An operation star is said to be binary operation on S. Suppose this star is said to be binary operation on S, means it satisfies the condition if for every A comma B belongs to S implies A star B belongs to S. That means any two elements of S can be taken and the composition star has been put between them. These A and B are the elements of S. The star is said to be binary operation means the A star B, the composition of A and B with the star, that result is also in S. Then the star is called a binary operation on S. If you want to the definition of a binary operation, try to remember this one. For every AB belongs to S, it implies A star B belongs to S. What is the star? Star is a symbol and often we call it as a binary operation. What may be the star? Where star is any operation, either addition or subtraction, multiplication or division, or it may be any defined new thing. On the set of natural numbers N. We said that the set of natural numbers on N. Students must to recall what are the natural numbers. N is a natural number. Suddenly what you have to be recall? Oh, N is equal to 1, 2, 3, 4, 5 and so on. Then the natural number N meaning has to be clear. On the set of natural numbers N, what is the addition? Addition is a binary operation on N. I said addition is a binary operation on N, multiplication is a binary operation on N, whereas subtraction and division are not the binary operation on N. So the conclusion, clearly to consider the natural numbers, any two natural numbers, 1 and 2 are the natural numbers. What does the 1 plus 2? Addition, 3. 3 is also natural number. So addition is a binary operation on N. To consider the multiplication of two natural numbers, 2 and 3, 2 into 3 is a 6. Immediately 6 is also a natural number. Therefore, that is a multiplication is a binary operation. Whereas subtraction, suppose 2 minus 5. 2 minus 5 is a minus 3. Minus 3 is not a natural number. Therefore, subtraction is not a binary operation on N. Division, 2 and 3. 2 divided by 3, it is a rational number, not a natural number. Therefore, division is also not a binary operation on N. So, the writing is very easy in theoretical part of a group. But to understand that theoretical means you should remember all the necessary content. If it is the natural number means you should recall what it is the natural number, then you will be clear. Take the another example on the binary operation on n. I will consider the natural number n. On n, star is defined as follows: a star b equal to a raised to b. For every a and b are the natural numbers. So our work is to check whether star is a binary operation on n in this case or not. A star b next defined 2a plus 3b. For every ab are elements of n. A star b is a 3 minus 4ab. For every ab belongs to n. A star b is a divided by b. For every ab belongs to n. Our question is, which of them are binary operation on n? We just only recall that natural numbers. Two natural numbers now written in this way: a star b equal to a raised to b. If the result a raised to b is in a natural number, then immediately star is a binary operation. I will say for the answer this one: for every ab belongs to n, a star b equal to a raised to b is also belongs to n. Therefore, star is a binary operation on n. For example, to consider a 2 and 3, 2 star 3. What happens? 2 raised to 3. 2 raised to 3 is a 8. 8 is also natural number. Yes, therefore star is a binary operation on n. Similarly, 3 star 2, 3 raised to 2. 3 raised to 2 is 9. 9 is also natural number. Therefore, star is a binary operation on n. To take a and b any natural number, the pattern a star b equal to a raised to b should be in a natural number. Therefore, whatever the first definition they given, a star b equal to a raised to b, this is always a binary operation. Therefore, the conclusion, star is a binary operation on n. Similarly, for every ab belongs to n, a star b is a 2a plus 3b. So, the multiplying 2 to the a and 3 to the b and adding, again we can get a positive round number. Therefore, star is a binary operation on n. Whenever the a star b equal to 3a minus 4b can be taken, minus is there. Minus number does not belongs to the natural number. Therefore, star is not a binary operation on n in this case. The fourth one, a star b is defined as a by b. The dividing numbers are not the natural numbers. Only the common numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Such numbers are the natural numbers. 2 divided by 3, 3 divided by 5. Such numbers are not the natural numbers. Therefore, in this case, star is not a binary operation. Hope the students you are getting the very clear idea about the binary operation and the binary composition. So, after the binary operation and binary composition, to go further, now the definition of a group, because the definition of a group must need the meaning of a binary operation and binary composition. Okay, now come across the definition of a group. An ordered pair G star, I put the bracket and G comma star. The two number has been written in a bracket, G comma star. I said this is a ordered pair. Ordered pair means the definite meaning of the G and the star. What is the meaning of G? Where G is any non-empty set and star is a binary operation on G. So clear it is. G is any non-empty set and star is a binary operation on G. If it is said to be a group, if it is satisfies the following conditions or axioms. If it should be satisfies the following conditions or axioms. So what are those axioms? First one is the closure law. First one is the closure law. What does the closure law says? For every AB belongs to G implies A star B belongs to G. For every AB belongs to G implies A star B belongs to G. That is the closure law. What is associative law next? It satisfies the associative law. Associative law needs the three elements. For every A, B, C belongs to G, A star of B star C equal to A star B of star C. And identity law. For every A belongs to G, there exists E belongs to G such that A star E equal to E star E equal to A, where E is called the identity element. It should be satisfies the identity law also. What is the inverse law? It satisfies the inverse law also. For every A belongs to G, there exists A inverse belongs to G such that A star A inverse is equal to A inverse star A is equal to answer is E, where A inverse is called the inverse element of A. If all the four conditions has been satisfies the G star, then G star is called a group. G star is said to be group means it satisfies the closure law, associative law, identity law, inverse law. It is the basic definition. You should remember all the laws. Suppose anybody asked what is closure law, we have to suddenly say for every AB belongs to G, A star B belongs to G, closure law. Suddenly asked associative law, you should be say A star of B star C equal to A star B of star C. What is identity law? Without hesitation you can say for every A belongs to G, there exists E belongs to G such that A star E equal to E star A is equal to A. Like that, you have to be frankly say all the laws. If it is a then what inverse law? You have to be say for every A belongs to G, there exists A inverse belongs to G such that A star A equal to A inverse star A equal to E. Have to be should be remember when you close after reading, after writing these laws, definition of a group, you should be recall and close your eyes and you have to be say frankly what is the closure law, associative law, identity law and the inverse law. Okay, then to go for the Abelian group or commutative group, we have to be consider a group G star. A group G star, what do you mean by a group G star? A group G star means G star satisfies all the four laws. Now after that all the four laws, it's said to be the commutative group or Abelian group means what is the condition? That to be no. Note, a group G star is said to be Abelian group if it satisfies the commutative law. What is that commutative law? For every AB belongs to G implies A star B equal to B star A. Abelian group means it satisfies all the four conditions of a group along with the commutative law, that is closure commutative law. That is what are the five laws? Closure law, associative law, identity law, inverse law and the commutative law. If all the five laws G star satisfies, then it is called as the Abelian group. So try to remember the definition of a binary operation group as well as the commutative group. Next, to go for the properties of a group. So these properties of group depends on the laws. First property, what it says, in a group G star, identity element is unique. In a group G star, identity element is unique. What is the meaning of this one? In a group G star. Oh, what you learned in a group G star means, oh, G star is a group means it satisfies all the four laws, closure law, associative law, identity law, inverse law. You should recall. In which identity element is unique. That means there is only one identity element in G. G consisting so many elements, but there is only one identity element. Clear it is? Okay, how to prove this one? G star is a group. I written let G star is a group. It meaning that, oh, G star is a group means all the four laws are satisfied. Consider any one element in G. For every A belongs to G. We know that identity element is unique, but how to prove? Suppose to take the two identity elements, then what happens? Okay, that to be written. If possible, let E and E dash be the two identity elements in G. For every A belongs to G, if possible, let E and E dash be the two identity elements in G. By definition of identity law, A is in G, E is the identity element. By definition of identity law, what happens? For every A belongs to G, there exists A belongs to G such that A star E equal to E star A equal to A. It is the definition of a identity law when E is the identity. If E dash is the identity, then what happens? A star E dash equal to E dash star equal to A. I am operated E to A remains same. I am operated E dash to A remains same. But it clears, that means E and E dash operated to A remains same. That means E and E dash are equal. From 1 and 2, it is very clear picture that E and E dash are equal. Suppose I taken there are two identity elements, but definition what happens? E and E dash should be same. It clear that identity element is unique. That means there is only one identity element. If you taken 2, 3, 4, but definition is applied, all are equal. Therefore, in a group G star, the identity element is unique. It completes the proof of the first property. Next to come the second property. In a group G star, inverse of every element is unique. G star, just in the previous property we observed that there is only one identity element in whole group. But group G containing, the set G containing so many elements. Suppose it containing for example 10 elements. If it containing 10 elements means every element having the inverse. 5 having inverse, 6 having inverse. But every element has only one inverse, not more than one inverse. For example, in multiplication, 2 is the one element. According to multiplication, its inverse is a 1 by 2. Because 2 and 2 cancel, we get a 1. other than 1 by 2, there is no inverse element of a 2. Therefore, it is the idea that in a group G star, inverse of every element is unique. How to prove this one? Let G star is a group. For every A belongs to G, if possible, let B and C be the two inverse elements of A in G. Let B and C be the two inverse elements of A in G. By inverse law, for every A belongs to G, B is the inverse of A. For every A belongs to G, there exists B belongs to G such that A star B equal to B star A equal to should be E, because inverse law says that A star A inverse is equal to A inverse star A is equal to E. Inverse of A can be taken as A inverse of A inverse we can taken as a B. Therefore, A star B equal to E by inverse law. Similarly, C is also the inverse of A, means A star C equal to C star A equal to E. Now, to consider a B. What to be write the B? B can be written as B star E because identity element. But E is replaced as a star C. E has been replaced as a star C. B star of A star C. Change the bracket by means of associative law. B star A star C. What is B star A? B star A is again E. E star C. E star C is nothing but a C because identity element B. So I started the answer question as a B. I get the B is equal to C. That means I taken B and C are the different inverse elements of A. But by definition what it says, B should be equal to C. That means every element having only one inverse. Suppose I taken more than one inverse, means those should be equal. It is the clear idea that inverse of every element is unique. So the two theorems are over. In a group, identity element is unique. In a group, inverse of every element is unique. Next, go for the property number 3. In a group G star, for every A belongs to G, A inverse of inverse is equal to A. Inverse of A is equal to A. Let G star is a group. By inverse law, for every A belongs to G, there exists A inverse belongs to G such that A star A inverse is equal to A inverse star A equal to E, because inverse law. So take this A inverse as a X. What happens? A star X equal to X star A equal to E. Now, what do you mean by A star X equal to E? What do you mean by A star X equal to E? A star X equal to E means the inverse of A is X or inverse of X is A. Means that inverse of X is A. How to write inverse of X is A? Inverse of X is A. But what is X? The X is A inverse. X is A inverse. Therefore, A inverse of inverse is A. So this is the proof of A inverse of A is equal to A inverse of inverse is equal to A. Next, go for the property number 4. In a group G star, A star B raised to inverse is equal to B inverse star A inverse. For every AB belongs to G. You can read inverse of A star B. Inverse of A star B. Inverse of A star B is equal to B inverse star A inverse. Inverse of B star, inverse of A. How to prove this result? Again recall that let G star is a group. To consider this expression B inverse star A inverse star of only A star B, the result should be E. How it is possible? Consider B inverse star A inverse in one bracket, between that star in another bracket A star B. You have to be freely change the bracket because associative law. I put the B inverse as it is. Now it is A inverse can be taken to this bracket. Next I grouped A inverse star A. But A inverse star A is a E because inverse law. Then E star B can be written as B. But B star B inverse as a E. What you get? I get that this whole result is equal to E. That is B inverse star A inverse star of A star B equal to E. So you can think like that. This is a X. This is a Y. X star Y equal to E. That means inverse of X is Y or inverse of Y is X. Now, what is this bracket? What is the inverse of this one? The inverse of this one is a B inverse star A inverse. Because the total result is E, means this bracket is inverse to the first bracket is inverse to the second bracket, vice versa. Because answer is E. So, what is the inverse of the second bracket? The inverse of the second bracket is nothing but the first bracket B inverse star A inverse. Therefore, inverse of A star B is B inverse star A inverse. So, this is the proof of the theorem, property number 4. Okay, property number 5 now. In a group G star, a solution of a star x equal to b and a star y star a equal to b exist and unique. Solution of means these what are the given a star x equal to b and y star equal to b, these are the equations. That means such equation, if it is a star x equal to b is equation, means we have the answer for this one. That will say that a solution of a star x equal to b exists and unique. That means it is a linear equation, x has the only one value to be proved, that is unique. Y star a equal to b, that means it has a solution and unique. How to prove the result? In a group G star, a solution of a star x equal to b, y star equal to b exists and unique. Start the answer, proof. Let G star is a group. What is our equation? A star x equal to b. So if it is A is in G, then A inverse is also in G because inverse law. Operate A inverse, this A inverse, throughout the left side on both the A star x equal to b. That left side multiplication is called the pre-operating A inverse. Pre-operating A inverse. So there is already A star x, I operated the A inverse star A star x equal to A inverse star b. To be change the bracket by means of associative law. A inverse star A star of x is equal to A inverse star b. What is A star A inverse? A star A inverse is a E. What is E star x? E star x is a x because identity law. Now A inverse star b is the x. This x equal to A inverse star b is the solution of A star x equal to b. To prove that this x has a only one value, not more than one values. To prove the solution is unique. Let x1 and x2 be the two solutions. Then what happens? In place of x becomes a x1 equal to A inverse star b. x2 is also equal to A inverse star b. That means these two are equal, x1 equal to x2, hence the solution is unique. Similarly, to take the second equation y star equal to b and multiplying A inverse throughout the right side, that is post multiplying, we get a y equal to b star A inverse. In the same way to prove y1 equal to y2. This is the proof of the theorem, proof of the property number 5. To go for the two very important properties in the group, that theorems I will say now, two important theorems. Theorem 1, in a group G dot I taken. Dot means instead of star I taken the dot as a symbol of binary operation or multiplication. In a group G dot, for every AB belongs to G, then AB whole square equal to A square into B square, double implies G is Abelian. What do you mean by double implies? A into B whole square is A square B square, means should be G is Abelian. And G is Abelian means it should be AB whole square equal to A square B square in a G dot. To prove this one, first I will take AB whole square equal to A square B square, and this implies G is Abelian. I want to prove. It is AB whole square equal to A square into B square. This AB whole square I will split as AB into AB. Similarly, A square I will split as A into A. B square is written as a B into A. Now it is clear, AB whole square is AB into AB, A square is A into A, B square is B into B. Change the bracket. A into B, A into B is equal to A into AB into B. Cancel the A on both the side by means of left cancellation law. What you left? BA into B equal to AB into B. Cancellation the right side B on both sides. B cancel by means of right cancellation law. What you get? B into A equal to A into B, or A into B equal to B into A. A into B equal to B into A means commutative law has been satisfied. If the group G commutative law satisfied, means it is a Abelian. Therefore G is Abelian. Now to take the reverse step, to consider the G is Abelian and to prove that AB whole square equal to A square into B square. G is Abelian. Therefore AB equal to B for every AB belongs to G. Pre-multiplying A on both the side, that A into AB equal to A into B. Post multiplying B on both the side, A into A already there, multiplying B, we get A into B equal to AB into B. AB into this one B. No, this is right. This is right. This A is right. Okay. Here it is multiplying B. Now it is A into A, B into B equal to AB into AB, because multiplied A is there, multiplying B. Now what is AA into BB? A square B square equal to AB into AB, AB whole square. Or we get that AB whole square equal to A square B square. So what you proved? G is Abelian means A square AB whole square equal to A square B square, or AB whole square equal to A square B square means G is abelian. Students, you have to try to solve these theorems in a group G dot. For every A belongs to G, A square equal to E, then G is abelian. Or in a group G, the two theorems are same. The question pattern is different. If every element having the own inverse, then G is abelian. Where it is A square equal to E means A into A is equal to E. What do you mean by A into A equal to A? When A comes this side becomes A inverse equal to A. The meaning of A square equal to A means A inverse equal to A. What do you mean by A inverse equal to A? Inverse of A is itself. That is, every element having the own inverse, then G is abelian to be proved. So I hope you have to be going for this videos again and again, and writing the notes on the papers, and preparing the group up to the whatever I covered. So one must to remember, these are the theoretical part things. Suppose I start the definition binary operation, should be remember, should be recall whenever the words comes. If it is the group, should be recall all the laws, then only it is very easy to make the study has to be okay in the easy manner. Continuing the next class. Thank you.